we continue on talking about relations that have infinitely many ordered pairs in them, one way that we can represent them is with equations, because we can write down x and y as arbitrary symbols, and then a point belongs to that relation if it makes the equation true. So for example, if I have y equals 2x, there are infinitely many ordered pairs of x and y values that make the equation true, and so that equation describes all infinitely many of those points. Okay. Topic 3 that we're taking a look at. So if you're following along on the worksheet, we've hit topic 3, although at this point we're not doing the problems from the worksheet yet. We'll do those in the next video. Okay. But trying to figure out whether an equation represents a function or not. So I just drew this picture here to remind us that if something is a function, it behaves like a machine, where if I know what x value I'm plugging in, the function's going to tell me to do something, and then I'm going to spit out a y value. And it's a function if it spits out a unique y value. So there aren't options here. There aren't multiple things that this could lead to. There's a unique output that I get. Well, when I'm looking at an equation, if I have something like this, where I have y by itself is equal to, and then some formula that doesn't have any more y's in it. So there's only one y in the equation, and it's by itself on the left-hand side. This just tells me what to do to x. That's going to be a function. And here's why. This is just telling me what the function does. I'm going to plug in a number. The function is going to double it. Now that's giving me very clear directions. And if I'm multiplying by 2, there is a right answer for that. If I plug in 3, well, 3 times 2, there's only one thing I can get, because there's a unique answer to that arithmetic problem. Okay, so if I have clear directions for what I need to do to x, and I can recognize that if I have y by itself is equal to some formula that just involves arithmetic and algebra operations, or even trig operations, which we'll be getting into later this semester, just involves those mathematical operations and x, then it's going to be a function. Okay. Now, if I have an equation like this, let's say I have x plus 2y is equal to 7. Now here, it's a little bit harder to see because I don't have the y by itself, but I can do a little bit of manipulation. I could subtract x from both sides, so I get 2y is equal to 7 minus x, and then I could divide both sides by 2, so we get y is equal to 7 minus x, all over 2. Notice the whole thing gets divided by 2. So now I have y by itself, and this just gives me directions for what I'm going to do to x in order to get out y. And because it's clearly defined what I need to do, and since there's a right answer that I get when I do subtraction and division problems, that tells me there's going to be a unique y value. Okay. So what sorts of equations don't give me functions? So certainly if y is already by itself, and just some expression involving x on the other side, I've got a function. If I can manipulate the equation to get y by itself, that's going to give me a function. What if I have something like this? X equals y squared. Well, here, if I wanted to try to get y by itself, I need to undo what I'm doing to x. What I'm doing to y. So I could try to take the square root of both sides. I could say the square root of x is equal to the square root of y squared. But I have to be super, super careful here. A lot of times people want to say, oh, the square root of y squared, that's just y. And it's not. The square root of y squared is the absolute value of y. Okay. That's because there's nothing that tells me whether y is positive or negative. Let's just suppose that y was equal to negative 2. Then y squared would be negative 2 squared, which would be 4. So the square root of y squared would be the square root of 4, but square roots, principal square roots, can never be negative. This would be 2. So here, the square root of y squared wasn't the same as y, but it was the same as the absolute value of y. Okay. But there are going to be two numbers that have any given absolute value if it's a positive number like this. Both 2 and negative 2 have an absolute value of 2. So if the absolute value of y is the square root of x, y would be plus or minus. There are two options. The square root of x. Okay. So that tells me, oh, that's two different options. That's not a unique answer, because that's not y by itself equaling one formula. That's y by itself equaling two formulas. There are two options for what y could be, so that this is not going to be a function. As a general rule, if you see even powers of y in your equation, you can expect that it's not going to be a function. So if I have something like x squared plus y squared equals 5, as soon as I see that even power of y, it's safe for me to conclude that this equation does not describe a function. Kind of nice to recognize that shortcut. In this case, I will be able to do the work of trying to isolate y. I could subtract the x squared from both sides. So y squared would be 5 minus x squared. The square root of y squared would be the square root of 5 minus x squared. Again, that's not y. That's the absolute value of y, which is the principal square root of 5 minus x squared. And then y would be, there we go, plus or minus square root of 5 minus x squared. I've got two options. I don't have a unique formula for y. So it's not a function. Okay. Now in this case, I can do that work. If I have an equation like this, let's say I've got x cubed plus y to the 5th plus y to the 4th equals 7. Here, I'm going to have a really hard time trying to solve for y and get y by itself. So here it's super nice to know the shortcut. That's an even power of y. I'm not going to have a function. So you're welcome to use that shortcut, though I encourage you in the simpler examples where you can actually go through and actually solve for y, to do that work so that you can see why even powers are going to lead you to multiple options for what y could be, and therefore not give you a function.